Okay, more problems with 10.3. This is number 47. We want to find the area of the region inside one loop of the lemniscat. R squared equals 4 cosine of 2 theta. So this is you can spend a lot of time looking at these lemniscats and trying to do this stuff, and it's really hard to do with a calculator because of the way it works. Because you've got R squared, you don't have R. So if you want to take the derivative of this, you can't put this in your calculator because your calculator puts R in. So if you want to put it in, it would be plus or minus the square root. So you'd have to put it in two different. You have to put it in two different, just like we do the square root, just like we do a circle. We have to put the positive square root and the negative square root in two different functions and graph both functions to get an idea of what it looks like. That's what you have to do with these lemniscats. So it's really, really bizarre. So the way you have to deal with this is just find from here to here, and that's going to be, because what we want is one loop, inside one loop of the lemniscat. So this is one loop. So what we'll do is we'll find the area from here to here and double it. All right? And that works out from 0 to pi over 4. Now we've got some bottom stuff going on here, and I try to see what's going on with these things, because when you graph these, it kind of goes like this, and then like that, and then you have a little space of time that goes like this, and then like that. So it's really strange what's going on and how they work. And this is also happening on the second curve. So if you try to graph them and you think too much about it, you're just going to end up in trouble, believe me. So, and I try to do these with functions. I tried all kinds of things, and this just seems to be the easiest way. And there's almost no way to check it on your calculator. That's the issue. So, probably have to do a little bit more research into this guy, because this is pretty curious. So what we're going to do is we're just going to double this. So we know if we checked on our calculator, this will give us from 0 to pi over 4. Will give us this top part. We'll just double it. So this area is 1/2 r squared theta d theta from alpha to beta. So we're just going to double that. We're going to take two of those areas, and we should get one loop. So, and if we doubled that, we would get the whole thing. All right. So 2 times the integral from 0 to pi over 4 of 1/2. Now this is where it is easier, being a lemniscat, to actually take the integral, because r squared is in the formula and it's set up for r squared. So we're just going to take 1/2 that. So that's a very easy integral to take. That's just going to be 2 times, and if I could take the 1/2 from the formula out in front, so that just becomes 1. So I just end up with 2 times the cosine of 2 theta. Well, actually just 4. I took this out. Now here's what I did with the 4. I broke the 4 up into 2 factors of 2 times 2. This 2 in front, and then the other 2 I put over here to use as for the chain rule, for the U substitution. So if you can see that. Okay. Now this 2 over 2 is 1, and then this 2 comes out, and I've got this set up. So I'm already to take my antiderivative. So I hope you can kind of follow what I did there. In other words, we're going to double this because we want the area of the whole loop. So we're just getting this top little portion here that I marked. Kind of shaded it. Okay. So we're going to take 2 times the area to get that. But I have a 1/2 in my formula, so if I take that half out, that's going to become 1. So that goes away. All right. So, and I probably should have, I had room for another step. I should have done another step. Okay. And then what we've got now is so that's out there, and I got a 4. So what I did with this 4 is I made it 2 times 2. That's the same thing. So I could use this 2 for the cosine for the U substitution. I take this 2 out, so this 2 goes here. So if you can see that. Okay. Okay, that 2 goes there because those become 1. Okay. And then this 2 goes there, and what happened was this 4 that's there and there. So hopefully you can see that. So I made that 4 go those 2 places, and now we're all set. Okay. So now we've got this 2 out in front, the integral from 0 to pi over 4, the cosine of 2 theta times 2 d theta, and this is all set for our antiderivative. and that's going to be the sine of 2 theta. And you can always check it. If you take the derivative of the sine, you get cosine of 2 theta times 2. And that's just 2 times that integral from 0 to pi over 4. If I put pi over 4 in here, I get the sine of pi over 2. Put 0 in here, the sine of 0. The sine of pi over 2 is just 1. And the sine of 0 is 0, so I just have 1 in here. That's 2 times 1 is 2. So all that for 2. Okay, so if that makes sense. And good luck with that one.